Alright, in this video I thought we would look at 6 of the properties of exponents. This is more of a pre-algebra overview, but there's 6 properties that we want to look at, and we're going to start with the product rule. And what the product rule of exponents says, it says if you have a base with a power, say 3, and you multiply by the same base with another power, what you're going to do is you're going to take and keep the common base, and since we have multiplication, those exponents are going to add. So x to the third times x to the second equals x to the fifth. That's basically the product rule. So to break it down, a product turns into a plus. Next rule we're going to look at is the quotient rule. And what the quotient rule says, it says if you have a base to, say, a power, and it's a fraction this time. Quotient means to divide, and a fraction also means to divide by the same base with a power. What you're going to do is take the common base, and you're going to subtract this time the top exponent minus the bottom. 3 minus 2 is 1. And remember, x to the 1 is just x, so we can leave it like that. And the way that I like to remember this rule is that a fraction turns into subtraction. A product turns into a plus, but a fraction turns into subtraction. Okay, next rule we're going to look at is the power rule. And what the power rule says, it says if you have a base to a power, and that itself is raised to another power, then those exponents are going to multiply. So this is going to become x to the 3 times 2, which is x to the 6th. And that's done. Again, the way I like to remember this one is that parentheses indicates multiplication even when it's between powers. So an exponent raised to another exponent, those are going to multiply. Okay, so there's 3 rules. Next rule we're going to look at is the zero exponent rule. And what the zero exponent rule says, it says that any base being a non-zero base raised to the 0 power is 1. So examples, 3 to the 0 is 1, 5 to the 0 is 1, pi to the 0 is 1. Any base raised to the 0 power is 1 as long as the base is not 0. Because if you have 0 to the 0, that's actually undefined. All right, next rule we're going to look at is called the expanded power rule. And what the expanded power rule says, it says that if you have several factors, like 3x y to the second, and all of that is raised to a power, say to the third. What I want you to notice is the expanded power rule is for monomials. That means inside the parentheses, you're allowed to have multiple factors, but there can be only one term. So here the 3 is a factor, the x is a factor, and the x squared is a factor. The expanded power rule says that that exponent outside is going to distribute to every exponent inside. So the understood power for 3 here is a 1. So 3 times 1 is 3. The understood power for x is 1. 3 times 1 is 3. And y has a squared, so 3 times 2 is 6. And then if you wanted to go ahead and expand that a little bit more, we can evaluate 3 to the third. 3 times 3 times 3, 27. X to the third, y to the sixth would be our final answer. And again, what the expanded power rule does is it allows you to take a monomial with several factors and evaluate raised to a power. Okay, we've got one more rule to look at, and that is the rule for negative exponents. And we're going to do maybe a couple of examples to demonstrate this. First, we'll do basic. Let's say that we have x to the negative 2 power, okay? So in mathematics, we don't like exponents to be negative. We want them to be positive. So I think what I'm going to do is show you the long way to work this first, and then I'll show you a shortcut. So we can write this expression as a fraction by putting it over 1. Remember, anything can be made into a fraction by putting it over 1. And then I'm going to multiply by 1. Now, I hope you agree that multiplying anything by 1 will not change its value. And do you also agree that anything over itself is 1? So I'm going to choose x squared. So x squared over x squared, that's equivalent to 1. So again, I'm multiplying here by effectively 1, so this is not going to change the value. And from the previous rules that we talked about, we know that when we multiply the same base here, we're going to add the powers. Negative 2 plus 2, that gives me a 0. 1 times anything is itself. And again, from the previous properties, we know that anything to the 0 power, as long as it's not 0, is 1. So I want you to notice what we've effectively done is started with something that had a negative exponent, and now we have an expression with x expressed to a positive exponent. And that is the very long way to do that. Let's look at how to do this with a shortcut, okay? So let's say we have b to the negative 3. We want that to be positive, so we're going to f it up. We're going to fraction it up. And just remember that negative exponents are unhappy. They want to be positive. So if the b is unhappy in the top, he wants to go to the bottom. Moving him down will make him happy. So that's going to become understood multiplication with the 1. When you move the b down, notice the exponent changes. And now notice there's nothing left in the top, so there's really an understood 1 left in the top. And we could get that from the fact that this b had an understood coefficient of 1. When we bring the b down, the 1 is still there. So that gives us 1 over b to the third. Okay, so can you remember that if you have a variable with a negative exponent, moving it down will make it positive. So what if it was negative in the bottom? Well, you would want to move it up to make it positive, okay? All right, so let's look at one more example, and then we'll call it quits on this video. Let's say we have x to the third over x to the seventh. Okay, so from our previous rules, we know that a fraction turns into subtraction, and you always subtract the top from the bottom. 3 minus 7, that's going to give negative 4. And we know that negative exponents are not happy. They want to be positive. So we can f this up, fraction it up. The x wants to come down. And that final answer is going to be 1 over x to the fourth. And so those are the 6 basic properties of exponents.